Hi guys, welcome back to my channel. This is Meena from Sri Venkateshwara College of Engineering from the department CSE. Now I am here to give the explanation about the topic called the use of quantifiers, definitions and proofs of theorems. Let us come across into the introduction part where we have to know about the definitions, quantifiers and proofs. Let us come across into the definitions. We all know that definitions are which provides the exact meaning to the concept so that everyone understands data in the same way. We can give an example as an even number is an integer which is also divisible by 2. It is a definition. Then quantifiers. Clarify the scope of a statement whether something applies to all the elements or just to some. For example, for all x in a natural number x plus 0 equals to x, where it is having a elements or just having a sum of the elements. Proofs. Validate whether the statement is true using a logical reasoning. Proofs eliminate uncertainty by showing why something must be true based on previously established flags and definitions. Then here comes quantifiers. Quantifiers specify the quantity of specimens in the domain of discourse for which a predicate is true. There are the two types of quantifiers, that is universal quantifier, extensional quantifiers. Universal quantifier means which we can take for all. Extension quantifier means which we are taking the there exists, which is some or that is. Then let us come across into the universal quantifier, that is which is denoted by for all x p of x, means p of x is true for all the values of x. For example, which we are giving x belongs to n, where we can give with it adding a 0 with it is equals to the x, which can give all the numbers for natural numbers. Extensional quantifiers denoted by there exists p of x means there exists at least one x for which p of x is true. Example, there exists belongs to n, x plus 1 equals to 3. We can give x equals to n. Here the value of x plus 1 is equals to, for some values it is true, other values we cannot predict it. Then combining quantifiers. Here multiple quantifiers can be combined. For example, we are taking x belongs to n and also the y belongs to n. Here we are specifying the condition as x is less than y. Meaning for every natural number x, there exists a natural number y which is greater than x. Next we come up into the definition. A definition is precisely describes the meaning of a term or a concept important for consistency in proofs and theorems. Example, an even number is an integer n such that n equals to 2k for some integer k. Has here definition which describes the meaning of a term or a concept which is consistency in a proofs and theorems. Here the even number is an integer. We all know that n equals to 2k. Here we are taking the example as n equals to 2k. K is an some integer. We can specify it. Then we come next to the proofs of theorems. Here first of all, proof. Logical argument establishing the truth of a theorem. Common proof techniques are direct proof, proof by contradiction, proof by counterpositive, proof by mathematical induction. Let us come across into the direct proof. A direct proof is one of the simplest and most fundamental method of providing a mathematical statement. It involves starting with known facts, assumptions, definitions or previously proven theorems and using the logical steps to arrive directly at the statement you are asked to prove. In a direct proof, you assume the hypothesis is true and show that the conclusion must logically follow from it. Then example of a direct theorem. Here taking the theorem as if n is an even integer, then n square is also an even. We have to prove that. We can assume n is even by defining even numbers. N equals 2k, n equals to 2k. Calculating the n square. N square equals 2k square, that is a 4k square. We can implement that as a 2 into 2k square. Conclude 2k into 2k square into 2k square is also an integer. We can write as n square equals to 2m, where m equals to 2k into 2n square. Then here therefore n square is also a even. We have known that this theorem is already proved in our last semesters or in these semesters we can prove. Then proof by contradiction. A proof by contradiction is a logical technique where you assume the opposite of what you prove, that is a negation. Show that this assumption leads to a contradiction, something that's impossible, false or conflicts with known facts. Conclude that original statement must be true because its negation is impossible. Then example for proof by contradiction. Theorem is root 2 is irrational. Assume root 2 is rational can be just be. Derive a contradiction. Conclude assumption is false. Where root 2 is rational means we have to add the not. This is negation. That is root 2 is not rational. That is root 2 is irrational. Then, importance of precise definitions and quantifiers, which ensures clarity and avoids ambiguity, helps verify the validity of proofs, builds a foundation for other theorems. Applications in computer science, algorithm correctness proofs, database query language, formal verification in software engineering, artificial intelligence reasoning systems. Thank you.